So now let's try to order these fractions from least to greatest. And we can use our number line to help us with that. We already know where 1/2 is going to be. That's going to be in the very middle of our number line because 1/2 is just half of the whole that we have here. So where would 1/4 be? Well, if we take a look at the 1/2 fraction piece, and then we compare it to the 1/4 fraction piece, you're going to notice that it's exactly half of the 1/2 fraction piece, which means on the number line, we can actually draw 1/4 halfway between 0 and 1/2. Alright, now let's see where 1/3 would be. If we take a look at our 1/3 fraction piece, you're going to notice that it's slightly bigger than 1/4, but also less than 1/2. So it should be somewhere between 1/4 and 1/2. So I'm just going to put 1/3 right here. Now lastly, we're going to see where 1/6 is. Now 1/6 is smaller than 1/4, so it's going to be somewhere between 0 and 1/4. So I'll put 1/6 right here. So now the correct order for these fractions from least to greatest goes 1/6, then 1/4, then 1/3, then 1/2. And you'll see that if the numerator is the same, in this case it's the number 1, that the larger the denominator is, the closer to the number 0 the fraction is. And this makes a lot of sense, because remember, the denominator just means how many of those pieces are there in total. So if we think back to our cake example, if I were to cut the cake into 6 slices and I only have 1 slice, that 1 slice should definitely be smaller than if I were to cut the cake into 3 slices and I only had 1 of those slices. Because the more times you cut that cake, the smaller the slices become. So let's do another example where we're going to order the fractions from least to greatest, except this time both the numerators and the denominators all have different numbers. So with our number line that we have, same as last time, we're going to try to place where these fractions belong. So right off the bat, I noticed that 4/12, represented by this fraction piece here, is actually half of 2/3, right? We notice that the 1/3 fraction piece and the 4/12 fraction piece fit perfectly together. So if you remember from the previous example, 1/3 was somewhere around here, because we had 1/4 here. And so if 1/3 is here, that means 4/12 should also be here. So I'll put 4/12 up here because they're equivalent. So let's move on to 3/4. Well, we know that 1/4 is the halfway point between 0 and 1/2. And we know that if we double it, 2/4 should equal to 1/2. So they're equivalent fractions. So I'll put 2/4 here, which means one more quarter after that, we should get 3/4. And now this makes sense because the halfway point between 0 and 1/2 is 1/4, and the halfway point between the half and a whole is 3/4. Now, where would we put 2/3? Well, I put 2/3 right between 1/2 and 3/4. And I'll show you why. Because in 3/4, how much are we missing to create one whole? Well, we're still missing 1/4, and then we would have a whole circle. But in 2/3, we're missing 1/3 to create the whole circle. Now, let's compare these two pieces, 1/4 and 1/3. 1/3 is greater than 1/4, and we saw that in our number line here as well, which means 2/3 needs a bigger chunk of that circle to create one whole. So it's actually further away from one whole than 3/4 is. Now let's use the same logic and see where 5/6 belongs. I'm going to say 5/6 should be right between 3/4 and one whole. Now that's the case because in 5/6 we're just missing 1/6, and in 3/4 we're missing 1/4. Now that means 3/4 should be further away from one whole than 5/6 is, because the missing piece is larger in 3/4 than it is in 5/6. So now the final answer for this question, ordering these fractions from least to greatest, actually goes with 4/12 first as the least, then 2/3, then 3/4, and then finally 5/6.